Okay, so this will start chapter 2. This is on the remainder limits and factor theorems. I think you might have covered these in Algebra 2, but I'm going to go through some back and review them. Some of you may not have had them. The remainder and the factor theorems. Remember, one of our goals in this chapter is to get to the point where we can solve a polynomial expression with a variable or a highest term greater than 2. And on this, I want you to be in Zoom. I want to go back and review. This goes all the way back to your Algebra 1 8 on your calculator. And I want to review dividing. Okay. And remember the limit notation, it looks like this. Say I want you to find the limit of x plus 4 by a as x approaches -3. Okay, remember right? Poly, prefix poly means many terms, okay. And a binomial. Remember, like if I graph this, okay, this would be like graphing a line. We're going to do this one a couple of ways. Say I give you as x to the -3 minus what's the y value. Remember the y value, the limit plus 7x on the y-axis. 2. Okay, so and it's all over divided by x minus 3. I want to take you back all the way back to the Algebra 1 to y sub 1. And if you were going to divide this out in Algebra 1, they did it by long division. And I'm going to have you. So we are going to divide this by long division. Okay, and if you put the trace key on, some of you may want to. And here's the problem. The reason I'm having you notice here, it's an x to the 4th and then a 3x squared. You have all those. If you want to put in a 0x cubed over here as a placeholder, so you may. Zoom, okay, but you don't have to. And press enter. It will regraph it. I'm going to show you what it looks like if you don't put it in. The trace key on. And then when you do the long division, as x approaches you look just at the first term here and the first term here, and you say, what do I need in my answer is so that when I multiply this times I would do a graph outside, I get exactly x to the 4th. So what do I need? Okay, we would have a line that looks like this. To the 3rd, because when you multiply x approaches, you add multiply monomials, you add the exponents. So we take the x to the 3rd times the value, and I get x to the 4th 1. Okay, the limit is red on the y-axis. X to the 3rd. The other thing for it to be a limit, okay. Also have to multiply the x to the 3rd times the -3, and it'd be -3x to the 3rd. The same y value from the left and the right. Okay. Okay. So if you have a limit on that graphically is 1. Okay. The next step is subtract. Okay. If you want to borrow, try another one. Here's some. You may need one. If they gave you the limit of 2x squared, just take some of those. As x approaches, next step is subtract. Okay. I just changed the signs on the bottom row. X squared. So graph it. Okay. Should graph a parabola. You change the signs on the bottom row. Then the x to the 4th drop out. Still in Zoom 8. Okay, now. You have to look as x approaches -2, the trace key are not like terms. Should end up to be 1's an x to the limit is 8. Okay, draw a sketch of that. So you bring down the the x to the 3rd. So bring down that term first, the highest one first. So I'm going to bring this one down. As x approaches, and it's -2. As x goes out here to -2. Okay, then I'm going to bring down the -3x squared. Okay. Okay. Let me stop there. Okay. Questions on that step? Yep. Okay, then multiply. One more. Let's do. We got to figure out what do I put up here in my answer, so that when I take it times x, I get exactly this first term. Just change your equation. So what do I need? 4x squared. Yeah, 3x squared, right? And it's plus. Still got a parabola. 3x squared. Okay. And it's gonna. So now you multiply 3x squared times x. But it is a parabola. 3x it would be a parabola that looks like this. Then you got to take 3x squared times the -3, and then give you a -9x squared. Okay, so put the trace key on. The next step is you subtract. Change the signs on the bottom row. Value was 16. Okay, so the limit. Okay, as x. So the 3x cubes drop out. Okay. Okay,
you should end
those are
up
regular
with
polynomials.
6x squared. A negative
And you
3
can just do
plus
them
9
graphically.
would be 6.
You can also do them just by
Bring down the
substituting
next
in.
term. Bring
Okay.
down this 7x.
Okay, the next thing
you got to bring down the plus
is
sign
the
with it.
rational function.
You look just at
Remember,
the first
anytime,
term here
we're looking at rational
and the first
functions.
term here.
That means you're going to have an x or
What do
a
I need in
variable
my
down
answer so that I
in the
get
denominator.
exactly 6x
Okay.
squared?
And let's look. We're going to do this
6x.
algebraically
So it's got to be
and
plus
graphically.
6x.
Okay, let's say I gave you the limit.
Okay, and then you multiply 6x times
the
x
quantity x
would
plus
be
3.
6x squared. 6x times a negative 3
minus 9
would be a negative 18x.
and it's all over x as x
Then you
approaches
change the signs
0.
on the bottom row because we're subtracting.
The
So
limit
change the
of
signs on the
x
bottom row.
plus 3, that
The
quantity squared,
6x squared
minus
drop
9,
out.
and it's
and you
all
have
over
25
x. Now, if you're
x.
doing that on the calculator,
Bring down the
you
plus
have to know
2.
to do
Bring
this.
down the next term.
You've got to know it's that whole
You
thing.
look only at the
numerator
first term.
divided by x.
You look at the x.
Okay, if we do it
And
algebraically,
you look at the
let's do it
25x
algebraically first.
and
If
say,
we
what
did
do
this
I need in my
algebraically,
answer?
Now, I
So
don't
when I
care if you
multiply
go
it,
across
I'm
your
going to need a
paper
plus
or if you go
25.
down.
You still need that
You have
limit
notation
25
on every
times
step.
x.
Okay?
Be 25x.
Until you let x approach
25
0.
times
so
a
you
negative
still need that
3
notation.
be a negative
Okay, so if
75.
we square this out, remember,
Change the signs on
this
the
is
bottom
a
row.
common error. When you square a binomial, you
Okay,
should always,
and the
always
25x's
get a
drop
trinomial
out.
square. You should always get 3
And
terms.
we're down to
The
77.
shortcut is square the
X
first
won't
one,
divide into 77, so this is a
multiply
remainder.
these two together.
Some authors
would be
write the
3x,
answer,
and then double it.
and it depends on your author. You have to look in the
And then
back
square
or
the
look at the
last one.
examples. Some
If you
authors
don't
write
know
it
how
as
to do that,
remainder
then
of
you gotta do it the
77.
long way. You
Some
gotta
authors put
multiply
a
this
plus
out,
sign and then put the
FOIL it
remainder
first out
over
and last.
that divisor.
Then bring down the minus 9.
I will take it either way,
It's all over
but
x.
you have to look at see how the author's doing
Okay,
it.
now simplify. The 9's go
Okay,
out.
that is long
Okay.
division.
And
That's
got
how
the
you did
limit.
it in algebra
Still need
1.
that notation.
Okay,
Limit
in
as
algebra
x
2, you
approaches
should have done it by
0.
synthetic.
Okay.
You'd have
Synthetic
x squared
is much
plus
easier.
6x.
And it's all over x.
Okay. Now, what can I factor out on top? Okay, on synthetic
An x.
division,
So I still need the limit.
okay. Now,
As x
over here I
approaches
did
0.
not put in the 0
Factor out an
placeholder.
x.
On synthetic, you have to put the
Remember,
0
the keyword
placeholder.
is to factor.
So, you look at the coefficients.
Factor it.
The coefficient's
reduce it,
1,
then sub in. You should
There
have
is
heard that last
no
year in pre-calc.
x cubed,
Factor
so
it,
it's 0.
Reduce it, then sub in.
Negative
So we're gonna reduce
3x
it. We
squared,
factored it. Now you can
7x,
reduce these x's
and then will
2.
divide out. And then usually on
Don't say they
synthetic, you
cancel,
draw the
'cause
bracket
canceling
this
means
way.
subtraction in math.
And
you can say they
what you
reduce or
divide
they
by,
divide
you really
out.
take the divisor, the x minus
And then you
3, you
have
set it
the
equal
limit
to 0, so x equals 3. So
Of
that's
x
what you
plus
divide
6
by. Another way to
as
say
x
that is just
approaches 0.
reverse the sign, that's what you put up there.
Okay? And now you can sub in.
Okay,
So
first step
when you
on
sub in,
synthetic is you just
that
bring this
limit
first number down.
notation is gone.
Bring
So
it
now
down.
sub in.
Okay.
And your final answer is
Then you multiply this
Okay.
number 1 times this number 3 and line it up underneath the second column. And then add going
then sub
down.
4 in. Yep.
Okay, now I said it twice
Okay,
already.
then you multiply
Divide
it down.
this 3
Factor
times
it,
this 3,
Reduce it.
line
sub
it up
in.
underneath the
If you
second
just
column.
sub 0 in,
and you
if you just
add
sub
going
0
down,
even if you sub
and you
0
multiply
into
this 6 times
you're going to
this
get
3,
oh well
would
it's
be
undefined.
18.
Well, no,
You
it's
should
not,
start seeing
because
these
you've gotta
numbers
factor
from
it,
over here.
Reduce it, and then
Add
sub
going down.
Okay.
Then you multiply
now,
this 25 times
Can
this 3
x equals
be
0?
75 and add going down. Now your answer on synthetic, you always
No,
take the
'cause you'd have
beginning
division by
exponent. So you depress it by
X
1.
cannot be
So
0.
this is
so that's
actually
either an
1
open
x
circle
to the
or
third
it's an asymptote.
plus
Okay, so now we're gonna
3x
find out on the
squared
Okay.
plus
In the graphic,
6x. You just go
Go back to the
descending
original.
order
You got to go
plus
all the way back to the
25
original column.
and a
Okay,
remainder
so do
of
parentheses,
77.
parentheses.
So
And then
this
x
number over
plus
here
3
is always your remainder.
quantity
Squared minus 9.
Okay.
Close the
That's
parentheses.
the remainder.
We're taking that
Okay.
whole numerator.
You remember that from
and
last year?
dividing
Synthetic?
by x.
Okay, so that's nothing
And
new.
let's
Good.
do
Okay.
let's do a zoom.
The next
We'll leave it
thing,
in
let's
Zoom
go
8.
through.
We'll do Zoom 8. Maybe I should ask you this.
Okay.
Did that factor divide out
Okay.
evenly?
Now put the trace key on.
As x
No,
approaches
because there's
0.
a remainder.
Okay. So is that actually a factor of that?
It's an open circle.
No.
Okay.
Okay,
And
it did not go in there
if you
either.
need to,
For it to be a factor, what's the remainder have to be?
If you want to go back to zoom, let's
Zero.
go zoom.
Okay. So
4. Let's see if what we got. No,
if
I gotta go zoom.
the remainder,
6. Go zoom 6.
okay, to get a better graph, then the divisor. Why is this graph in a line? Why is it not graphing a parabola? Is a factor because you're dividing by x. We're taking an x squared and dividing by x, so we're down to an x to the first. Okay. So as x approaches 0,
it has to go in there evenly.
you're going to end up with
0.
an open circle there. It's
Let's
not
look
an
at another
asymptote.
example. In the book, they will give you a problem like this.
And as
let
x goes to 0,
P of x,
this y value,
and usually when they're saying P of x, it's like a polynomial.
6. That
P of
y
x
value is 6,
equal
but it's an open circle.
2x to the third
What that's
plus
telling you
x minus 2.
You're coming in to 0 from both the left and the right.
Show
What y value is
P of negative 2
coming
is the remainder.
from both. It has to come to the.
For there to be a limit,
It has to come in from the left and the
when
right to a y value.
P of x
Even though that y value is an open circle.
is divided
So the critical part on that is you got to go all the way back and look at this. X
by
cannot be 0.
x plus 2.
So either it's an asymptote or it's an open
Okay,
circle.
so P of
In this
negative
case, it's
2
an open circle.
is the
The
remainder
limit is
when
6.
P of x is divided by x
Okay.
plus 2.
So factor
Okay,
it.
first
reduce
thing,
it,
sub in,
okay.
is take the P of x.
Let's do
And
one
sub
other thing.
in.
Do second function format. Turn the axis off.
Sub in, they want you to find P of negative 2. So sub in negative 2. Everywhere you see an x, and you've got to do the
Sometimes
order
that
of
will- you'll be able to
operation.
actually see the open circle. It was right on the axis. So to be able
So you
to
got to do
see
those
it,
exponents
I turn the
first.
axis
Negative
off.
2
And that's
cubed.
that's on second function format. And sometimes you
Negative
gotta
times a
turn the
negative times a
axis
negative
off.
would be negative 8.
Okay.
Okay, so
Okay, and I get a negative
you
16
might do,
minus 2 minus 2.
second
Be a
function
negative 18
format.
minus 2
And
would
turn
be a
the
negative
axis off.
20.
So P of negative 2
And you'll be able to see that open
is
circle
20.
then.
Okay.
Where
Now
the
they want you to
pixel's
show
missing.
that that's
I won't
the
say
same
that
as
you'll
if
always
you
be able to see
divided
it,
that
but
by
most of the time you
x
will.
plus 2. Okay, so take the coefficients up here. So
Sure,
this would be
yep,
2.
yep.
There is no x squared
Okay,
term,
now
so
the
it's
author
0,
goes through some theorems on the
1,
limits.
negative
And I
2,
just use THN
and then
for
we need to
theorem.
divide by
In theorem
what?
1,
Part A.
negative 2.
A lot of
It's the
these
same,
you
whether
already
you're
know,
substituting it in or
but I want
dividing
them
by
in
it.
the notes.
So
Okay,
first step on synthetic, you just bring that first
a
number down.
constant.
Okay, and then
function.
multiply. 2 times a negative 2 would be negative 4. Add going down.
F of x equals,
Okay, and then you multiply
they're using
negative
k
4
for the
times a
constant.
negative 2, be a positive 8.
First,
Line
let's
that
stop
up.
right there.
Now
F of
add
x
going
equals a
down.
constant.
Okay. And then 9
Example.
times a negative 2 would be a
F of
negative
x
18.
is the same as y.
Add going down
Constant
would be a
would be
negative
like
20.
5. Y
Okay, the
equals
remainder,
5.
what's that going to
is
graph?
right there.
Okay. And it says,
What kind of line?
show that
Horizontal.
P of negative
Okay.
2 is the remainder.
Okay.
What they're trying to
For
get you
any
to see
horizontal line,
is that you can
like
get this
I said, y equals
remainder.
5.
Now
And
you've
I'm
got
coming
3
in
ways to
any
get
x
the remainder.
value.
You
What's the
could
y
do it by
value?
long division.
5.
Most of you will probably do it by
I already know this
synthetic
one.
division. But
Then
they're trying on this problem to get you to see
for any
that you could do it just by subbing it in.
value
Okay, it is the remainder.
of C,
You just sub it in.
the
Okay,
limit
so the author goes through
of
the
x
remainder theorems as
Okay.
x approaches some C value equals the limit of k as x approaches C,
right,
or
equals
equals
k.
negative 20.
Yep, that's good enough.
They're just substituting in on this.
F
Yeah,
of
she's
x
asking,
is
how do you
k,
write
so
it? You could just
substitute
say on this one,
k
if they ask
into-
what's the remainder,
But if this
it's
was
negative 20.
5, the limit
Say
of
R is
5
negative 20.
is 5.
The remainder theorem says
The limit of a
if
constant is
itself a
Okay.
polynomial. Okay, part B. If P
F
of x
is the identity function, is divided by x minus r, that's a lowercase r, f of x, the remainder equals x. That's the identity function. That's the same as y is a constant. What's that going to graph? Y equals x. It's a line that goes through at 45 degrees. P of r, didn't we talk about that line on inverses, that it's symmetric about that line? P of x, so for any, if you think polynomial equals the divisor, x minus r, times the quotient, q of x, plus the remainder. If this is the line when what y value is that going to come to? The polynomial p of x equals the divisor, x minus r. They're using q of x is y equals x plus the p of r for the remainder value when for all of q of x. So you already know this is a polynomial for any value of c. The limit 1 less of f of x as x approaches c, and the degree is c. Okay. Of the original polynomial p of x. Oh, sorry, c. So what that's really saying, so if I said, go back up here, on the identity here's your divisor, x minus r. If you wanted to check long division, x as x approaches to 4. Check it, you would take this, it's going to be, that's your 4. Q of x. That's like your quotient, right? You would take this q of x times this x minus r, and then you would add on that remainder. That's all they're saying. C, to check it, that's how you would properties do it. Of limits. Okay, let's do one more example. Properties of limits. I'm going to just do this as an example. Say they let book, it'll say find the remainder equal x plus 4. And g of x is 2x squared. When, if they said, what's the limit plus 8x plus 4 plus 1 as x approaches 1 is divided by, this is just minus polynomial. Okay. So you don't now I want you to find the answer to reduce two ways. Just sub in. I want you to find it by what I call synthetic substitution. Don't make this hard. Substitute it in. Okay. If I said find the limit of 2x squared, it better be the same answer as x approaches 1. Okay. If you're doing it by synthetic substitution, just write it as p of x. Right? If I said now let's figure x plus 4, the limit of x plus 4. What are we going to sub in? Plus 2x squared, 2 or negative 2, as x approaches 1. Now, look at the one up above. If this limit of x plus 4 as x approaches 1 is 5. This one, the limit of 2x squared as x approaches 1 is 2. So if I add these together, what would you guess? You're still approaching 1. 7, because you're adding them together. Right, I'm adding x plus 4 plus 2x squared. Right. Okay. No, that's good. Okay. These aren't bad. Okay, now let's do another example. So on that one you add, okay, the limit. You should end up with the remainder. Let's do another example. Say they ask you to find questions on that one. The limit. Up in the numerator, do x squared minus 25, and it's all over 3 times the quantity x minus 5. We basically already said it a minute ago. And the binomial x approaches 5. Now, as soon as you get a variable down in the denominator, x minus r, you have to remember to factor, reduce it, and then sub in. The error is just to sub in 5 polynomial p of x. Well, it's undefined because I'd have division by 0. IFF cannot do that.
Okay, you got to factor it, reduce it, then sub in 0. Okay, so let's factor. How do you factor the difference of two squares? Substitute it in. The remainder has to be 0. Okay. Yep. Okay. You got to factor it. 1 plus sign, 1 minus sign. X plus 5 and X minus 5. Doesn't matter which one goes first. You still need that limit notation. So you factor it. Now you can reduce it. These two divide out. They will reduce. Okay, so then you're down to the limit of X plus 5 over 3 as X approaches 5. Now you can sub in. Okay. Okay, so you just sub it in. So you're going to put 5 in what it's approaching. You put 5 in there, so 5 plus 5. When you sub in, the limit notation is gone on this step. So 10/3 would be your answer. Okay. Now go all the way back to the beginning. Can X equal 5? No, because you would have division by 0. So that is either an open circle or it's an asymptote on your graph. Okay, so let's graph it. You have to know, the author is not going to tell you this, you have to know to put parentheses around this and put parentheses around this. Okay? So we need parentheses and then x squared minus 25, close the parentheses, divided by, and then do parentheses 3, parentheses x minus 5, close the parentheses, close the parentheses. And let's do zoom 6 to start. Okay. And now if you did second function calculate value at x equals 5, here's how you tell you've got an open circle. There's no value down here for y. Okay? So when you graph it on your paper, you want to show that open circle. Looks like it's crossing about 2. And as x approaches 1, 2, 3, 4, 5. So as x approaches 5 up here, you got an open circle. And what's that y value? 10/3. So it's 1, 2, 3, 4 would be up here. So this value, this y value that it's approaching is 3 1/3 or 10/3. So as x approaches 5, but you do have to show that as an open circle. So star it if you haven't already. If you were taking a calc test at college, this is at least probably 2 letter grades. If you don't factor it, reduce it, sub in. Factor it, reduce it, and sub in. You cannot just sub in. It's not that easy. Okay? Now, that goes all the way back, and we need to refresh your memory on factoring a little bit. You look for what's in common, difference of 2 squares, like we did up here, difference of 2 squares. But in your Algebra 2, you factored sum and difference of 2 cubes. You cannot factor the sum of 2 squares, but you can factor the sum of 2 cubes. From Algebra 2, okay, if that's a plus sign, the sign inside the first set of parentheses is plus. And then it's a squared minus ab plus b squared. If I had something like this, if I had like, let's say I had 64x to the 6th, or x to the 3rd, plus 27. Okay, I would not try to factor it like that. I rewrite it first. 64 is a cube of what number? 4. So this would factor into x. That's my a, is 4x. And 27 is a cube of 3. So this is the a, this is the b, and then I fill it into this pattern. So it would factor into 4x plus 3 times, what, 16x squared minus 12x plus 9. Okay? Don't try to go from just this. Figure out what's the A, what's the B, and then factor. Okay, that was one pattern. The other pattern was if they changed it to a minus. Okay, if that's a minus, then the first sign inside is minus, and then A squared. Notice there's no 2 in front of this. It's just AB, and then plus B squared. Okay, so that's the other pattern. You have to memorize those if you don't have them memorized already. Okay, so the author is going to give you problems that involve cubes. Okay, like this. Say they ask you to find the limit of x cubed minus 1 over x minus 1 as x approaches 1. You cannot just sub that in. If you've got a variable down in the denominator, you've got to factor it, reduce it, sub in. Okay, so if we do, this is an x minus 1. So our A is x, our B is 1. Still need the limit notation as x approaches 1. Factor it, we'd have x minus 1, and then x squared. Multiply them together would just be plus x, plus 1x, plus 1. And it's all over x minus 1. That stays the same. Now you can reduce. These will divide out. They will divide out and reduce. Okay, and you still have the limit notation. And you got x squared plus x plus 1. Okay, now you can sub in. So 1 squared would be 1, plus 1 would be 3. The limit is 3. Okay, now graph it. Let's graph it. Do a little sketch. And you got to know when you put it in to do this. Okay, can x be 1? No. So that's either an open circle or it's an asymptote, so you can check it on your graph. Okay, put in parentheses x cubed minus 1, close the parentheses, divided by parentheses x minus 1, and I'm going to do zoom 6 to start. Okay, why is that graph in a parabola and not a cubic? Because you'd have x to the third divided by x to the first is an x squared. That's why it's showing up as a parabola. Okay, and x, if you did second function calculate value at x equals 1, it is an open circle. Okay, so graphically, you're going to have, and as x approaches 1, the y value is 3. So you get something like this. Oops, sorry, I'm going to need an open circle in there. Okay, this is kind of quick on the graph, but as x approaches 1, you got an open circle. Okay? So I would highlight on this assignment up at the top, open circles, kind of as a reminder. Open circles and factor. Okay? Okay, the last example. If they said find the limit of x squared plus 1 over x plus 1 as x approaches negative 1. Can you factor the sum of two squares? No, because you'd always get a middle term. You can't factor it, okay, so you can't reduce it. So now just sub in. If you sub in, what are you going to get in the denominator? 0. Okay, so graphically. Okay, and you got to know to do this. Okay, so x squared plus 1 divided by, put parentheses around the x plus 1, and zoom 6. Okay, at x equals -1, is it an open circle? It's an asymptote. Okay. Okay. You're actually graphing a hyperbola, and you actually have a. This is not exact. Okay. You have a diagonal asymptote on this, don't you? And then you got something like this. This isn't exact, but this is your graph here, and something like this. This is pretty rough. Okay. Now, here's your -1 right here. This asymptote, that vertical line. Okay. As x is coming in to -1, what's this y value going to? Positive infinity. As x is coming into the left, what's this y value going to? Negative. So, are they coming into the same y value? No. No limit exists. Now, if the author turned this around and said, what's the limit of x as x approaches -1 from the right side? Okay, this says as x approaches -1 from the right side. Now, what's the limit? Positive infinity. And if they turn it around coming in from the left side, it's going down to negative infinity. Okay? Okay.